Hello everyone, welcome to Geeks for Geeks. So let's talk about today's problem. Our problem name is minimum cost path. So let's first read the question. Our question said, we are given a square grid of n size, each cell of which contain an integer cost that represent a cost to traverse through that particular cell, right? So we need to find a path from the top left cell to the bottom right cell by which the total cost is minimum, right? Okay, so from the cell ij, right, we can go from four directions. Either go to the top of it, either go to the bottom, either left or right, right? We have four directions, right? So at the end, I just want to need that particular path which give me the minimum output, right? Minimum sum, right? Okay. Now let's see how we can solve this problem, right? Okay. So let's see for this case, right? In this case, if you see here, we just have four directions, right? At my source will be at this place right now, top left part, right? Okay, and my destination will be this, right? I just want to reach this part, right? This is my destination and this is my starting part, or we can say that that's my source part, right? Okay, now see, I am here, I have four directions. Either can go to the up, either go to the left, either go to the bottom, either go to the right, right? Okay, so these are the four directions which is given to us, right? Okay, now when I will reach to this case, now again we have four directions, right? Here four directions, here four directions. At every cell you have four directions, but we just have to choose very frequently so that my answer will be the minimum, my path will be the minimum, right? Okay, so if you see in this case, this is my starting path, right? I can take this path to reach my answer, right? 3. Okay, in this case, if you see, my output will be look like this. So we just traverse these cells. So what is my output in this case? 23 and 26 and 29, right? Okay, so this is the one path. Okay, now let's see for other case. Now for example, I just go here and here I just change my path, right? And after that, this is my path, right? So this is the one path. So in this case, if you see, my output ka sum will be 15, 22, 25 and 28, right? That's another path. Okay, now let's see the other path. Okay, now if I see like this, I am here and I can go like this, right? Okay, so this is also a one path. So in this case, my output will be this, right? So what's the sum? Sum is 26. Now we have many other paths, right? Okay, you can go like this. Okay, you can go like this. So let's check other case. So you can go like this. This is another path you have, right? But in this case, what's my output? My output will be, if I do the sum, that particular sum will give me this, right? So in this case, it's 13, 22, 28, and this will be 31. So out of all, my answer will be 26, right? So I just want to calculate the smallest sum, right? So your target will be the top left part. Your starting point is the top left part, and I just want to go to the bottom right part, right? I want minimum sum, right? We have four directions. So that's the question. Okay. Now just visualize this problem. This problem is similar to your Dijkstra algorithm, right? If you know that particular algorithm, it's very simple. We just have to use all the similar things in that case also, right? We can use this problem. We can solve this problem by using priority queue, right? Min heap, right? So if you're not aware of Dijkstra, I just recommend you all, please first see that particular part. After that, that question is very, very easy, right? Okay, now let's see how we can do that. So in this case, what I'm doing is, I know that when I reach to any cell, we have four paths, right? We have four directions. So what I'm doing is, I simply make four direction ka array, right? Okay, four directions. So I just make two arrays, right? So the first will be your row part and the second one will be your column part, right? Okay, now suppose this is my row array and this is my column array, and we know that four paths we have, right? So I just make sure that particular ka size will be 4 like this, right? Okay, now see, when I'm here, I go to the top because I'm at 0 0, right? So if I go to the top of it, what's my changing in my this particular row and column, right? It means my column will increase, right? Up. So where is my column? 0. So I just make sure that will be -1 and column will be same, which is 0, right? Okay, If I go to the bottom of it, it means my index will increase in the bottom part. My row will be increased in the bottom part. It means from 0, I just make sure that I am reaching to the 1 of it. So what I'm doing is I make here 1 and column will be same, right? We are at the 0th column. Okay. Now, after that, I go to the left of it. In the left of it, my row will be changing, right? No, my column will be changing, but my row will be same, which is 0. Column will be decrement, right? From 0 we just go to that particular in the left direction, that will be -1, right? Okay, now if I go to the right part of it, that particular part, the row will be same, right? And my column will be increased +1, right? That's the thing which you have to make sure, right? So yeah, that's clear, right? Now what I'm doing is I simply make the priority queue, right? So just remember that particular part in Dijkstra, we use the min heap, right? I just want the minimum path in Dijkstra, right? Shortest distance from all the vertices. Here, I just want minimum path to reach to the bottom right part, right? Now let's see how we are solving this. To solve this, so let me make this down, right? So just make a note of it, all the 4 directions, right? Okay, now what I'm doing is I simply make a vector array, right? Vector or vector array. Now in this case I just make the same n cross n size of it, right? Whatever the size we have. Okay, in that case what I'm doing is I simply make sure that particular will be the whatever the value here we have, and rest all just make sure that will be the infinite. Okay, so I just make 10 raised to by 9, right? So that it will no out of bound part, right? Okay, so just make sure, just write 180 power 9. Okay, right now I just write the infinite, right? Okay, now this is the path. Now in the Dijkstra part, what we are doing is we just make the min heap, right? That particular min heap contains 3 things here, right? And what is that? First is your element weight, right? What is your number itself, that is this. And tell me what is that particular index, row and column. That is 0 0, right? That's what we are putting into it, right? So this is your min heap, right? PQ part. Okay, let me write here. The first one will be the weight of it, and the second one will be the row and column part. Okay, like that. Okay, now what I'm doing is I simply go to the min heap, right? And I pop out that particular part, and I'm written here what is my weight. Weight will be 9. And can you tell me the row will be 0 and column will be 0, like that. Now see, I simply go 4 directions as the 4 direction I mentioned here, right? So I simply see, okay, this is row. Right now I am here. Let me change the color. So right now I am here, right? Right now I am here. I am seeing I can go to the 4 direction. Can I go to the top of it? Just think about it. Top means what is row? Row right now I am 0, right? So this will be the -1. So can I go to the top? No. So we just have to write the condition so that we are not out of bound of that particular grid, right? Okay, I do not go in the top of it, right? Okay, can I go to the bottom? Yes, we can, right? So here what I'm doing is this is my right now string part. So I am asking 9 plus. Right now I'm here. Can I go to the bottom? Yes, you can go to the bottom. Now I'm thinking 9 plus 6, which is 15, right? So here what I'm doing is 9 plus 15, which is okay, 9 plus 6, sorry, 9 plus 6, which is 15, is that particular is less than whatever we are present in that particular vector. Let's suppose that particular ka name will be wasted, right? Okay, is this greater? Yes, it is. Let's change that particular part. So what I'm doing is I make change here. What is the change? 15, right? Okay, so I just make sure that particular 15 is 9 plus 6. That's why I just update that, right? Okay, after that you see what is my answer, right? How we can calculate the answer, right? Okay, now I cannot go to the top, I cannot go to the left of it, I can go to the bottom of it. I update my answer here, right? Okay, can I go to the right of it? Yes, we can, because 9 plus 4 is 13, but here we have infinite. Let's update that part, because my target is I want the minimum sum, right? Let's update that, right? Okay, whatever we are updating now, please add that particular into PQ and respective their column and rows, right? So I update that part. So let me write here 15, and what's that particular index? That will be 1 and 0, right? Okay, after that we update the right part. that is 13, and here we have 0 and 1, right, like this, right? Okay, now after C, now when I again go to the min heap, that particular is the element which you have to extract, and let's cross this. And in the second case, what's my weight? Weight will be 13, and what is my row? Row will be 1 and column will be 0, like this, right? Okay, let's cross this. Okay, now it means we are here, right? Okay, now if you see here, I'm asking here, right, this is 13, right? Can I go to the top? No. Can I go to the left of it? Yes, you can go, but 13 plus 9, that will give me 22. But here we have 9, right? I don't want to update that part, because at the end of the day, I just want the smallest sum, right? This is 9, and 13 plus 9 will give me the maximum answer, right? So I am not able to update that part. So can I go to the bottom? Yes, you can. But 13 plus 7, here we have 13, assume like that, this is my 13 and this give me 7. So 13 plus 7 is 20. But here we have infinite. Can I update that? Yes, you can. So what I'm doing is I update that part as 20, right? Okay, now after that, can I go to the right of it? Yes, you can, because here we have 13 and its left right will be 9. 13 plus 9 is 22. Okay, but we have infinite. Let's update that part, right? So what I'm updating, please add into your PQ as well, right? So 20 will be updated, which is index 1 1. After that we have 22 and index will be 0 2, right, like this, right? Okay, after that I choose the minimum is 15, right? So let me write here third part, this is second part. So what is my weight? Weight will be 15, right? And row will be 1 and column will be 0, right? It means we are at this case. Now can I go to the top? No, because 15 plus 9 is greater than 9, right? I don't want to update that. Can I go to the left? No. Can I go to the bottom? Yes, you can. So in that case, 15 plus 8, that will be 23. Let's update that. So this is I update. What I am updating, please add into your PQ as well, right? And can I go to the left of it, right of it? Just tell me, can I go to the right of it? So 15 plus 7, that is 22. Here we have 20. Why I update the maximum, right? We are not updating that, right? So that's it for the 15 part, right? Okay, after that we choose the minimum, that will be 20, right? It means we are here. So can I go to the top? No. Can I go to the left? No. Can I go to the bottom? Yes, you can. Here I just update 20 plus 3, which is 23. Okay, let's update here as well, which is 23, and your index will be 2 1, right, like this. Okay, after that, can I go to the right of it? Yes, you can, because we have infinite here, right? So 20 plus 6 will be 26, right? Here I update like that. Okay, so let's update here 26, and what is the indexing part? 1 into, like this, right? Okay, after that we take the minimum out of this, which is 22. Let's cross this, and let me write here your weight will be 22 and row will be 0 and column will be 2, right? It means we are at this case. Now here, can I go to the top? No. Can I go to the left? No. Can I go to the bottom? 20 plus 22 plus 6, which is greater than 26. So I am not interested. Can I go to the right? No, because it's out of bound, right? Okay, so 22 is processed. Now after that, let's see for this case. At 2 0, we are here, right? Can I go to the top? No. Can I go to the left? No. Can I go to the bottom? No. Can I go to the right? Yes, because right take infinite, right? So 23 plus 3 will be 26. Let's update that. After updating that, so let's make here the rest of it 26, and here I'm adding 2 comma 2, like this. Just assume this is also your PQ, right? So we have some space issue here. Okay, now after that 23 to 1. So 23 to 1 means, so we are here, right? So I just write like this, weight will be 23 and row will be 2 and column will be 1, right? Okay, now when I am here, I am not able to go to the top. Okay, I think it's done, right? It's done. Okay, after that we are at 26 1 2, right? Okay, we are at 26 1 2. Now when I am here, just see here, when I am here, I cannot go to the top, I cannot go to the left, because left will be 20, right? That particular itself is 26. Can I go to the bottom? No. Can I go to the left? Right? No. So that particular part is also processed. After that, we left with this. So this particular part, can I go to the top? No. Left, let's check. So it's 26, right? So 26 plus 3, which is 29, but it's 23. I don't want to update that. Can I go to the bottom? No. Can I go to the right? No. So in this case, this is also processed, right? Now, at the end of it, whatever we stored here now, we know that that particular index, that particular index which stored 26. So let me mark 26 here. This is 26. Okay, that particular your value will be the minimum sum which start from the top left and we reach to the bottom right. That's what we have to do is right. Now let's see the code of it. Okay, so in this case what we are doing is the first step, right? The first step, we calculate the size of your grid, right, in the row part, and we calculate the column part, how many columns we have, right? After that, what I'm doing is I simply make the wasted part, right, and I just add a 1 10 raised to per e value, which is maximum value, right? We are not adding the infinite because infinite plus something is out of bound, right? That's why we just take care of that. Okay, so here I just make a grid which is a copy of that particular your grid ka size n cross n. I just make sure this particular will also be n cross n or n cross m, whatever we are given in the question, right? So I mark all that particular as infinite or 10 raised to power 9, whatever you assume, right? Now I know that the first value will be the grid of 0 0, right? And I just make sure that particular will be grid 0 0. After that, I simply make the min heap of it, right? We know that how the min heap in C++ we make like this. After that, whatever we are taking the first value, which is top left value, I just make sure that particular ka value plus its indexing row and column, just add that particular into it, right? Okay, after that I just make the 4 directions array row and column, right? And after that I just go to the while loop and my current is pointing at top of it and pop that particular part and make sure what is the weight current dot first, right? And after that I just make sure what is my row and column which we extract from my PQ, right? Okay, after that I just go for the for loop, which is 4 times, right? And I just check my current value, current row and current column, and I'm asking here, hey, can you please check first is that particular is in my range or not, right? If it's in the range of that particular part, it's not out of bound, right? We can access the that particular element which is exist, right? So that's why this if condition is checking that part. Now after that we just have to add the minimum value at that particular grid ka index, right? So I'm asking, hey, whatever the weight we have plus your grid ka weight, right? Okay, is that particular sum will be less than whatever we have present in my visited array which we make, right? So in that case, if the infinite 10 raised to 9 value is present, please update that with particular value. With of that particular row and column, please update that particular value because it's smaller, right? Only in that case my if condition is satisfied. And whatever we are updating in my vested array, we just have to push that particular into my PQ, right? So that we can go forward to reach my destination, right? Okay, now in that case we just push into it, right? And at the end of it, as I tell you in the triangle part, key whatever we are present in my last bottom right part, that is my smallest path from my starting part, right? That's it, what we have to do is, right? Now let's see it's working fine or not. Okay, yeah, it's working fine, right? Now let's talk about a time complexity, right? So if you see here, what I'm doing is I simply make the vested array, right? So its space complexity, extra space we are using is whatever the size of your grid is, right? So let's assume it's n cross m, right? After that, what I'm doing is I know that I'm processing each and every element in my grid once time, right? So we can say that that particular while loop will run n square time. Yes, we can say that. But in that particular case, what we are doing is we are popping it and we are pushing it. If you see here, now to add any value in your PQ, how much time it take? It depends upon your size of your log, right? What is the size of that particular PQ you have? So we can assume like that it's log n part, right? If I say n will be your grid ka size, n cross n. So we can say that it's log n part, right? Okay, that's it. So we can say that my complexity is n square log n, right? Okay, so what is your time complexity? Okay, so your time complexity will order of n square log of n, right? And what's your space? we are making a space that will be the vested array which we are using, that is n square, right? So just assume like here n or n equal to m, right? You can also replace like that, both are nm, right? You can also assume like that both are correct, right? So hope you understand the solution in tuition. Thank you so much.